Hello, this is Robert Davies with the Utah Climate Center. In this episode of Utah Climate Notes, it's time to turn a corner. We spent some time now better understanding climate change's intensifying risks. Now it's time to examine what we know about reducing risk, a basic roadmap to mitigating extreme climate change. So, Earth is warming. Driven by human carbon emissions, principally from the burning of fossil fuels, this warming is disrupting the planetary climate system, posing extreme risks for humans. The bottom line: dangerous climate disruption is underway, catastrophic disruption is probable, and we've got about 2 decades to, fix that. Yeah, that's right, I don't get invited to parties anymore. Well, is that the end of the story? Not quite. Certainly we have a mountain to climb. And we've never climbed this mountain, but we have climbed others. As it turns out, we have everything we need. We have all the gear and a map. We need to move to a low-carbon civilization, and we need to do so quickly. And does our study of climate change have any insights as to how this might happen? Well, there are many potential components to reducing carbon emissions and moving away from fossils. But because of the short window for action, the roadmap in this discussion sticks to existing technology that is ready for deployment. And there are just two legs. The first is on the demand side of energy, where energy is consumed in our homes, businesses, and industry. This is refrigerators, lighting, airplanes, automobiles. You get the picture. And the second leg is on the supply side of energy. And this is how energy is produced. It's electrical power plants, gasoline and jet fuel, etc. So let's look at each leg in turn. Progress on the demand side is all about energy reductions. Now, this is a powerful piece of the puzzle, and here's why. Looking at electrical generation, for example, for every 10 units of energy that actually does something for us, produces light, runs the refrigerator, powers your electric toothbrush, we must actually consume, on average, 50 units of energy. And that's because the things that do stuff for us are inefficient. Incandescent light bulbs use most of their energy to produce heat, for example, not light. But it gets even worse. In order for that light bulb to consume 50 units of energy, the energy grid must deliver 54 units of energy to the pole outside your house. And that's because some of this energy is lost transferring it from the grid into your house. What's more, and this is a big one, in order to deliver 54 units of energy to your doorstep, so to speak, the grid must actually produce, wait for it, 120 units of energy at the generating station. And that's because transmitting that power over long distances consumes energy, a lot of it. Finally, in order to produce 120 units of energy, the system must ingest 133 units of energy, again because the process isn't 100% efficient. So one needs to shovel 133 units of coal energy into the burner, for example, to end up with 120 units of energy heading into the grid. And so we see chopping 10 units of energy from our use in the home actually saves 13 times that much in carbon dioxide belching energy production. Now, you might say it seems like a tall order to get everyone in the world to start chopping their energy consumption. But here's an interesting fact: not everyone needs to. It turns out that 10% of the world's population is responsible for 50% of the world's energy consumption, and 20% of the population consumes 80% of the world's energy. So that's the demand side. Deep reductions in consumption by 20% of the world's population. But what about the supply side? Well, the strategy here is entirely about massive deployment of zero-carbon technologies we already possess. Here, the empirical evidence demonstrates that we already have what we need. Consider that in the first 3 months of 2016, the United States saw nearly 1,300 megawatts of new electrical generation capacity coming from renewables, chiefly wind and solar. Now that's enough to power more than 250,000 homes. In that same time period, there were just 18 megawatts of new generation from natural gas, not clean, not renewable, and a whopping 0 megawatts of new generation from coal, oil, and nuclear. Around the world, the story is evolving even faster. In May of 2016, for example, Portugal powered itself entirely from renewable energy for 4 straight days. Germany, the world's fourth largest economy, was nearly 100% renewable for a day, and Great Britain, the world's ninth largest economy, ran without coal for a full week for the first time in 130 years. It's clear then that we have the knowledge and technology. What we need is radically scaled up deployment of the zero carbon technologies, technologies that we already have, that are already economically viable, and that we're already deploying. So, is this roadmap doable? Yes, the science strongly suggests that it is. Will it be easy? Fair question, and the answer, of course, is no. But we should add that this question must be considered jointly with another question. Is mitigating the risks of a 4-degree world harder than dealing with the realities of a 4-degree world? To our 4 pieces of knowledge, then, we should add a 5th. We know that we already have what we need to move quickly away from fossils. Now, the same cannot be said about having what we need to adapt to extreme climate change. And we should also consider the ancillary benefits of moving away from fossils. I mean, hey, did you hear the one about the massive solar panel spill that polluted the entire Gulf Coast? Well, me neither. Secure, affordable, clean, locally produced energy is pretty much its own reward. We're going to get there sooner or later. Climate change dictates sooner. So that concludes our whirlwind tour of the science of climate change. Now, obviously, we have only touched on many, many topics. There's more to say and to know about every aspect, about the climate system itself, impacts to both human and natural systems, the science of adaptation, and the science of mitigation. This series has been intended not as the definitive work, but as a jumping-off point for digging deeper. Utah Climate Notes is a collaboration between the Utah Climate Center and Cooperative Extension, making essential climate science real for the people of Utah.